Hello everyone. I welcome you all to yet another session wherein we'll be discussing a question from slightly higher level difficulty, right? From the basic regular preparation that students will be having usually. So this is the question that we have for the day, right? So let us look at this question. But again, before we start solving it, what I would suggest is please pause the screen, right? Pause the video for now. Try it out yourself once, right? Now after you're done trying it out, we shall discuss it. Like, you can just continue watching it, right? However, I would be straight away taking up the discussion further. Let's get started with this. It says if 1 into 2 into 3 into 4 plus 1 is 25, 2 into 3 into 4 into 5 plus 1 is 121. All these are perfect squares, if you'll see. 3 into 4 into 5 into 6 plus 1 is 361, 19 square it is, right? And so on. Find the value of 32 into 33, 34 into 35 plus 1, square root of that, right? So let's look at this. So when you look at this particular equation given, so 1 into 2 into 3 into 4, when you look at this, can we actually write it down as, right, general term, if you look at it, can we write it down as n into n plus 1 into n plus 2 into n plus 3, right? This is how we can write it down, right? Plus 1, of course. Let's try to simplify this. Let's see what do we get. Now for simplifying this, there's one small observation I want you to learn here, right? Observe here and learn from here, which is if you multiply first and last term and multiply the middle two terms, you'll get a major common portion. I'll just try to show it to you. If you multiply first and last, you'll get what? N into n plus 3, n square plus 3n. If you multiply second and third term, you'll get n square plus 3n plus 2. You're getting a common term here. N square plus 3n is common, plus 1, right? Now, if I put n square plus 3n as some k, let n square plus 3n be k. So when you put this as k, the given expression will become k into k plus 2 plus 1, which when simplified will become k square plus 2k plus 1, which is a perfect square, right? Because I can write this as, this in the form a square plus 2ab plus b square. If you'll see, we can write it as k plus 1 the whole square. So thus can I say the square root of it. Finally, if you look at the question is asking you square root of it. So when you find out the square root of this particular thing, it will give me k plus 1 as the final answer. Now what is k plus 1? K was nothing but n square plus 3n. My answer will be n square plus 3n plus 1. So just observe here. Here for this first equation, what should be our answer? So if you look at the answer should be n square plus 3n plus 1. Let's understand what is n here. N is 1. So 1 square plus 3 into 1 plus 1 is actually 5. So basically square root of this, should be equal to 5, which is actually a fact. If you'll see, it's 25 square root, which is 5. Here n is equal to 2. So when you put n equal to 2, you'll get 2 square, 4, plus 3 into 2, 6, plus 1. Now what is the square of it? Or when you take the square root of it, what should you get? Root 121 is 11, which is actually correct. Going ahead in the same manner, here can we say my answer, n is equal to 32 is the value. So if n is 32, what will we get here? We'll get n square plus 3n plus 1, where n is 32. So when you put n equal to 32, you'll get 32 square. So how much is 32 square? It's 1024 plus 3 into 32, 96 plus 1. So when you solve this, you'll get 1120, 1121. So the answer that we should get here is 1121. All right. So what's the value of this? We'll say the answer finally it's 1121, and this should be our final answer. All right. So with this, I hope the question was clear. Here, the important thing to learn was how do we simplify terms involving product of 4 consecutive integers like this, right? How do we simplify that? So this is how we do it. I hope this was clear, right? Thank you and all the very best.